the system I am talking of. In discrete time, input is represented as x of n, output is represented as y of n, and system behavior is h of n. System behavior is h of n. Okay. For discrete time system, we can apply only DTFT and Z transform. Z transform, it is x of z. DTFT means it is x of e power j omega. This x of n is time domain. This is time domain. This x of z and x of e power j omega is frequency domain. Frequency domain. And for continuous time signal, if the signal is x of t, continuous time signal is x of t, we can apply continuous time Fourier transform, Laplace transform on continuous time signal. Okay. So for x of t, we cannot apply the transform. For x of n, we cannot apply Laplace transform. Okay. Continuous time, we can apply only CTFT and Laplace transform. Discrete time, we can apply only DTFT and Z transform. Now we are talking about discrete time system. This is the diagram I am taking. H of n is giving the system behavior. So H of n gives the system characteristics or his system behavior, and it will also relate the input and output. If we are applying Z transform of input, Z transform of output, and Z transform of system behavior. Now, if you make output by input in Z transform, if you make output by input, this is called transfer function or system function. This is called transfer function or system function. And if you write them in continuous time, this is frequency domain, I told you. Okay, y of z, x of z is frequency domain. If you write it in time domain, y of n by x of n. If you write it in time domain, y of n by x of n, this is called gain. In time domain, it is called gain. In frequency domain, it is called transfer function. In time domain, it is called gain. In frequency domain, it is called transfer function. Okay, already I told you x of n, it relates the input and output. X of n system behavior, it relates input and output of the system. That is represented as an equation. That equation is also called difference equation. In continuous time, it is called differential equation, relating input and output by system behavior. That is differential equation in continuous time. We are talking about discrete time, so that equation is called difference equation. In general, nth order difference equation is given by, summation ak y of n minus k equal to summation bk x of n minus k. So n minus k means delay units. And ak, bk are constants. So for a, I will take k equal to 0 to n. For b, I can take k equal to 0 to m, which means number of constants need not be same. This is equation 1. This is nth order difference equation. Generally, we know y means output, x means input. This is a relation between input and output. If you take the RHS term to LHS, that will become minus. RHS, you can put 0. That becomes equation. Okay. This is also equation. You can bring the input also to LHS and make RHS as 0. Okay. So you can see AK, BK are the constants. Y is output, X is input. N minus K are the delay units. And then K equal to 0 to N means N plus 1 number of constants or n plus 1 number of terms are there for output. K equal to 0 to m on RHS, K equal to 0 to m means m plus 1 number of terms there in the input. AK, BK are constants. Okay, which mean K equal to 0 to n, K equal to 0 to m means number of output terms, input terms need not be same. Number of AK, BK coefficients need not be same. The count, number of coefficients need not be same. Okay, this is equation 1 representing nth order difference equation. Now we will go with a problem. A discrete time system is specified by difference equation. Y of n minus 1.5 y of n minus 1 plus 0.5 y of n minus 2 equal to x of n if the initial conditions are y of minus 1 equal to 1, y of minus 2 equal to 0, and if the input is x of n equal to 2 power n u of n, find the total response. Find the total response. Okay, I will go to solution. I will go to solution. So we already know total response is nothing but, so total response is nothing but natural response plus forced response. Natural response plus forced response. Total response can be written as y total. Natural response can be written as y natural. Forced response can be written as YF. Okay. So we have other names for natural response. Other names for natural response is nothing but homogeneous solution. Homogeneous solution or free response. Free response. Free means no input. So other name is zero input response. Other name is zero input response is also name for natural response. ZIR, zero input response. So if you go to forced response, this is sum of homogeneous solution plus particular integral. Okay, this is sum of homogeneous solution plus particular integral. Plus particular integral. Okay, forced response means input exists. Forced response means input exists, but initial conditions are zero. Initial condition of the state, which is nothing but system. System initial conditions are zero. So we can also call it as zero state response. Zero state response. It is ZSR. It is ZSR. Okay. So natural response means zero input response. Forced response means zero state response. Now we are supposed to find total response. I will start with finding natural response. Finding natural response or homogeneous function. Okay, I will find natural response or homogeneous function. Given equation is y of n minus 1.5 y of n minus 1 plus 0.5 y of n minus 2 equal to x of n. Okay. So what I will do, y of n I will assume as lambda power n. Okay, this I am making assumption. Then y of n minus 1 I will take lambda power n minus 1, and y of n minus 2 I will take lambda power n minus 2. Input is 0 because I am calculating natural response. Natural response means 0 input. Free response means 0 input. Okay. So I will write lambda power n minus 1.5 lambda power n minus 1 plus 0.5 lambda power n minus 2 equal to input is 0 because we are calculating natural response or free response. If you take lambda square as constant, if I take lambda power n minus 2 as constant, common factor. Lambda power n minus 2, if I take common in all the terms, I will be having lambda square minus 1.5 lambda, okay, plus 0.5 equal to 0. Now I am taking only this thing and get the factors. Get the factors for this. Okay. I am going with only one fact. Lambda power n minus 2 equal to 0. Lambda power n minus 2 value equal to 0. Now the quadratic equation is there, lambda square minus 1.5 lambda plus 0.5 plus 0.5 equal to 0. Okay. So how I can write this? 1 into 0.5 is 0.5. If I take, I should get minus 1.5. Okay. So minus 1 into minus 0.5. Minus 1 into minus 0.5. So if I add these two, it will give us minus 1.5. So what I will do here, lambda square minus 1 into lambda minus 0.5 into lambda plus 0.5 equal to 0. In the first two terms, I will take lambda common. In the second two terms, I will take minus 0.5 common. Okay. and if I take lambda minus 1 common, it is lambda minus 0.5. So the factors are, lambda values are 1 comma 0.5. Factors are like this. So homogeneous solution I can write as, homogeneous solution I can write as, it is equal to, C1. Okay, here what I have is two factors, lambda 1 value is 1 and lambda 2 value is 0.5. General format is C1 lambda 1 whole power n plus C2 lambda 2 whole power n. Okay, this is the general format of homogeneous equation. Homogeneous equation. We know lambda 1 value is 1, 1 power n plus C2, okay, lambda 2 value is 0.5 whole power n. Okay, this I am making it as equation 2. This I am making it as equation 2. I have C1, C2, two constants. C1, C2, two constants. So in homogeneous solution, input is 0, but initial conditions exist. Initial conditions exist. Okay, so I have to consider the initial conditions given in the question. I am having initial conditions. If you see, y of minus 1 equal to 1, y of minus 2 equal to 0, y of minus 1 equal to 1, y of minus 2 equal to 0. Okay, so in this is y homogeneous of n, y homogeneous of n in equation 2, in equation 2. Okay, so what is y of minus 1? What is y of minus 1? Wherever n is there, I have to put minus 1. Wherever n is there, I have to put minus 1. Okay, C2 0.5 minus 1. Okay, so what will happen? A power minus n is nothing but 1 by a power n. Okay, so 1 power minus 1 is 1 by 1, value is 1 only. 0.5 whole power minus 1 is nothing but 1 divided by 0.5. 0.5 means half, so 1 divided by half is 2. 1 divided by half is 2. I am going to use this here. I am going to use this here. Okay, already initial condition y of minus 1 value is 1 here. Y of minus 1 value is 1 here. So LHS I will put 1. This is equal to C1 into 1 plus 2 times C2. This be equation number 2a. Okay. So now in equation 2 what I will do? In equation 2 what I will do? Wherever n is there I will put minus 2. Wherever n is there I will put minus 2. Okay. Plus C2 0.5 whole power minus 2 in equation 2. In equation 2, wherever n is there, I will put minus 2. Why only minus 2? Because in the initial condition, we have y of minus 2 value. That's why I am putting y of n value as minus 2. Okay. So already it is my 1 power minus 2 means 1 divided by 1 square. It is value 1. 0.5 whole power minus 2 means 1 divided by 0.5 whole square. So 1 divided by 1 by 4, which is nothing but 4. Value is 4. Okay. So this is the constant I am calculating. So already LHS y of minus 2 value initial condition is given as 0. So I will put 0 on the left side and right side it is C1 into 1 and here it is 4 into C2. This is equation 2b. This is equation 2b. Now solve 2a, 2b. Put them one below the other, 2a, 2b. Okay. So what you will have is C1 plus 2 times C2. If you subtract, it will be minus 1. This will cancel. And here it is 2 times C2. Okay. And the C2 value is minus half. C2 value is minus half. If you put C2 value in equation 2a, if you put C2 value in equation 2a, okay. So 2a will give 1 equal to C1 plus 2 into minus half. Okay. So this minus 1 on RHS, if it come to LHS, it is 1 plus 1. So C1 value is 2. C1 value is 2. C2 value minus half. C1 value is 2. Okay. I am going to put this in equation 2. Now I am going to substitute the constant values in equation 2. So homogeneous solution is nothing but C1 value 2 into 1 power n. C2 value minus half into 0.5 whole power n. This is equation 3. Homogeneous solution is completed. Equation 3. Homogeneous solution is completed. We have taken input as 0 and the initial conditions, whatever given in the question, we considered for this calculation of homogeneous solution.